Good morning, dear student. Hope you all are doing well. In the previous video, we have discussed about the definition of solutions and also the definition of solvent and solutes and actually the rule of the solvent and solutes in the preparation of the solution. Okay, and also we classify the solution mainly, primarily we classify the solution on the basis of the nature of the solvent into three categories. Okay, and again on the basis of the nature of the solute, we further classified the three categories of solution into further subcategories. Okay, and we have already discussed all of them. Okay, so in this video class, actually we will discuss or we will actually learn about the ways of expressing the concentration of a solution. Okay, so here we are talking about what? The expressing the concentration of solutions, or way of expressing the concentration of a solution. So what do you mean by actually concentration? We are talking about concentration. Okay, so what is the meaning of concentration actually? So we already know that solution is what? Solution is actually what? Solution is homogeneous mixture of two or more than two components. If two components are present, let's suppose only two components are present in that solution. Okay, then between these two components, one will be what? One component which amount is large will be solvent, and the other component which amount is low will be solute. Okay, and since only two components are present, so the solution is what? Binary solutions. We already discussed these things in the previous class also. Okay, and suppose the solution is prepared by more than two components. Okay, that means more than two components are present in that solutions. Okay, then the one which is in the large amount is solvent. Okay, that means only one solvent can be present in a solution. Okay, because this is the largest, only one will be largest than the others. Okay, so only one solvent will be present in a solution. Okay, and the other components will be what? Other components are your solutes. It may be two solutes, or it may be more than two solutes. So we are able to know that the amount of solvent is actually in large amount than the other components, that means other solutes which are present in that solution. Okay, so now coming back to the concentration terms, actually the amount of the solute present in that solution determine the concentrations actually. So if the amount of the solute present in that solution is very high, then the solution is known as concentrated solutions. Okay, and if the amount of the solute present in that solution is very low, okay, then the solution is known as dilute solutions. But the thing is that here, okay, these two terms, that means the concentrated and dilutes, will not actually tell you the exact amount present in that solutions. So how much amount of solutes are present in that solutions or in that solvent? Okay, we cannot say by using this concentrated or dilute terms. Okay, understand now? That means by using the only dilute, so if you only say that it is a dilute solution, so how much dilute, how much solutes are present in that dilute solutions, or how much solutes are added to that solvent to prepare that solution? You cannot say. Okay, that means these two terms, that means this concentrated and dilutes, these two terms, or the concentrated solution or dilute solutions, are actually what? A qualitative expression of concentrations. So that means it will not going to give you the what? Give you the quantitative aspect. That means it will not going to say how much amount of solutes are present in that solutions. Understand? So that means we can express the concentrations by two ways. One is what? Qualitative way of expressions, which includes the mainly two subclass, which is what dilute solutions, or you can say that we can express qualitatively the concentration of a solution by saying that the solution is concentrated or dilute. I think you have already gone through this type of terms in practical, okay, in the preparation of some solutions in titrations. Okay, we basically prepare some solutions of sodium chloride, or sodium hydroxides, or some acids like HCl. These are prepared from concentrated solutions. Now we prepare some dilute HCl solution from concentrated HCl solution by adding some amount of water. Okay, but if you only say that this is a dilute solution, or this is a dilute acid, or this is a concentrated acid, by saying the concentrated acid or dilute acid, it will not going to give you the idea how much actually amount of the solutes or how much amount of the HCls, okay, molecules are present in that solution. You cannot say. Okay, you can only give the qualitative explanations. Okay, that means the quality of these solutions. Understand? And the second is that second way is or second way of expression of the concentration is actually quantitative expression. Quantitative. Okay, that means we can exactly say how much amount of solutes are present in that solutions, or we can exactly tell actually how much amount of solutes will be added, okay, or which we have to add it to that solvent to prepare a specific solution. Understand? So in this topic, we will basically discuss about the quantitative expression of concentration. Okay, so if someone asks you what is actually qualitative expressions of concentrations, then you have to say about the above two expressions. Okay, that means the dilute and concentrated solutions. Okay, understand? But actually there are some drawback. Okay, there is a drawback of these types of expressions, that is actually we cannot know the exact amount of the solute present in that solution. Okay, so that's why we need some other expressions of concentration which can be actually which can give the exact amount of solutes present in that solutions, or the exact amount of solutes which we have to add to a specific amount of solvent to prepare a specific concentration of solution. Understand? And that is actually known as, we already know that is known as quantitative approach, or we can say that quantitative way of expression of concentrations. Actually nowadays our world become a very small place in terms of connectivity, but earlier it's not like this. Okay, so there were scientists, there were many scientists, okay, in different corner of this world, and they are far from each other. Okay, and they are far from each other concepts as well. Okay, so they use different techniques to represent the concentration or to express the concentration quantitatively. So we have different ways of expression of concentrations due to the above factors, as well as the different technical inventions. Okay, so actually the different technical inventions also leads some different way of expressions of the concentrations. Okay, so we have basically different ways of expression of concentrations quantitatively. Okay, we understand these things, and actually some ways are depends upon the percentage of actually the percentage of the amount of substance or the components present in that solutions. Okay, so that is we compare the amount of solutes with the amount of solutions. Okay, we can understand it by using as for example like your percentage, marks percentage. Okay, so in which actually in case of your percentage of your marks, what you do, you actually divide your marks, your total marks by the maximum marks, okay, and into 100%, okay, like this. So we can actually, like this, we can divide the amount of solutes, okay, actually amount of solute, or you can say amount of component, okay, present in that solution divided by the amount of the solutions, understand, into 100% to get the actually information about the concentration, actually how much percentage of solutes are present in that solutions, understand. So actually there are mainly three this type of expression, okay, this percentage related expressions, and they are actually, you know, a mass percentage, or sometimes it is known as weight by weight percentage, or sometimes it is known as weight percentage also, okay. So this is the first expressions of concentration, and second one is volume percentage, or volume by volume, or volume by volume percentage, and third one is mass by volume percentage, or it is represented by W by V, or it is also known as weight by volume percentage also, okay. So actually the above expressions have some you know, similarities, like, you know, you see you know, here in case of mass percentage of a component, we divide mass of the component in that in the solution by total mass of the solution into 100%, and in case of volume percentage, we have, you know, just replace the mass by volume. In case of mass by volume percent, we have to divide the mass of the component, or mass of the solute, by volume of the solutions, okay. And usually the volume of the solution in the third case, actually this, you know, mass by volume percentage, the, you know, the volume of the solution is taken as 100 ml, okay. So that means we able to understand that we can express the concentration, or we can have the you know, informations, actually how much amount of solutes are present in a solution, by knowing the amount of percentage of that solutes which are present in that solution, understand. So these are the three way of expressions which are related to the percentage of solutes which are present in that solutions, okay. It may be mass percentage. If we talk about mass percentage, then we have to use the mass of the solutes and mass of the total solutions. And if you talk about the volume percentage, then we have to use the volume of the solutes divided by volume of the, you know, the solutions. And if you talk about the mass by volumes, then we have to actually use the mass of the you know, the solute, and also we have to know the volume of the solutions, understand. So these are all about the expressions of, actually the way of expression of the concentrations which are related to the percentage of the solutes, understand. So now let us, you know, discuss about this way of expressions of the concentrations one by one in details, okay. So in this class we will basically discuss about the first one, which is you know, the mass percentage, okay. So we can understand these expressions of you know, concentration by using a question, okay. So the question is, let's suppose what do you mean by 10 mass percentage of glucose solutions? This is your questions, okay. So, or the question may be put like this way also, okay. What is the meaning of you know, 10 weight by weight percentage of glucose solutions, okay. So actually the answer will be like this, okay. Actually here, if you read this question, the question is what do you mean by 10 mass percentage of glucose solution? That means here glucose solutions are prepared in where, actually if nothing is given, only it is only the solute is given here, na, the where solute is what, glucose solute, okay. And it is prepared in actually water. If it is nothing, if they did not mention about the solvent, then it actually does, then you have to consider the solvent as water. Okay, that means here the glucose is prepared in water, and also this is already we know that glucose solutions are prepared only in water. Okay, so here the solute is glucose, understand, and here it is already they already told you that the percentage of this solution is what, 10%. That means 10% of the glucose should be added in that solvent to prepare the 10% of solutions. Okay, so here it is, because it is 10 mass percentage, that means we have to add what, 10 gram, understand. If you want to prepare 10 mass percentage of glucose, that means you have to use 10 gram of glucose, and you have to add that 10 gram of glucose in 90 gram of water. Remember that point. Okay, 90 gram of water to make the solution into 100 gram of solutions, understand. The net solution should be, the net weight of the solution should be 100. Okay, so that means if you prepare the if you want to prepare 100 gram of solutions, okay, then you have to add 10 gram of glucose in 90 gram of water to prepare that 100 gram of glucose solutions, understand. So if you want to prepare let's suppose 100 kg of glucose solution, then you have to use 10 kg of glucose solute and add with it what, how many, 90 kg of water to make it 100 kg of glucose solutions, understand. And mathematically it is expressed as mass percentage of a component is equal to mass of the component of in solution divided by the total mass of the solution into 100. So it is actually the mathematical expressions, because what is the meaning of it? Actually, you see here, if you put the value of this, mass of the component in the solution, it is what, 10. Okay, because the mass of the solute or mass of the glucose here, it is 10 gram, and the total mass of the solution is what, 100 gram. We make it 100 gram by adding 90 gram of water. Okay, so it will be into 100%, then it will be what, then it will be your 10%. That means the mass percentage of the component or the solution is what, the solution is of 10 weight percentage of, or 10 mass percentage of solution, understand. Let us take another example. Let's suppose the question is how you will going to prepare 50 gram of 10 mass percentage of glucose solutions. So this is very simple. Okay, so here we already know that to prepare 100 gram of solution, we need to add 10 gram of glucose in 90 gram of water. Okay, so that means 50 for preparing 50 gram of this 10 mass percentage of glucose, we have to add just 5 gram of glucose in 45 gram of water, because we have to just divide this 10 gram by 2 and this 90 gram by 2 to get this total 50 gram of solutions. Simple. Okay, now let us take another example, and the question is let's suppose how will you prepare 500 gram of 3.6 mass percentage solution of sodium hypochlorite in water. Okay, so in this type of questions, actually these types of questions are related to what, percentage of solutions. Okay, percentage. So when we are talking about percentage, that means it is related to 100, understand. So that means here you see in the question it is given that we have to prepare 3.6 mass percentage of solutions. How much? 500 gram. Okay, so first of all, what is the percentage? 3.6 mass percentage. That means actually we have to prepare 100 gram of this 3.6 mass percentage of solution. We have to add actually 3.6 gram of sodium hypochlorite. So what we can write? We can write here that to prepare 100 gram of solutions, always remember this 100 gram. Okay, because here we are talking about percentage now, so we are writing here 100. So to prepare 100 gram of sodium hypochlorite solutions of this 3.6 mass percentage, we need to add 3.6 gram of sodium hypochlorite. Okay, that means to prepare 100 gram of solution, we have to add 3.6 gram of sodium hypochlorite. And to prepare 1 gram of solution, how much solute or how much sodium hypochlorite we need? We need 3.6 gram divided by 100. Understand? And it will be your this amount. Okay, that but now question is what? Now the question is actually we have to prepare 500 gram. Okay, so here to prepare 500 gram of solution, we need 3.6 into 500 divided by 100 into 500 gram of sodium hypochlorite. Okay, so if you calculate this, then it will going to give you actually 18 gram of sodium hypochlorite. Okay, so that means what? That means what? We have to add 18 gram of, or we actually need 18 gram of sodium hypochlorite solution, not solution, so sodium hypochlorite solute. That means the solid. Okay, sodium hypochlorite, we need 18 gram sodium hypochlorite, and we have to add this 18 gram of sodium hypochlorite in water to prepare 500 gram of solution. But how much water we need actually? To calculate actually how much water required to prepare this 500 gram, we have to just actually use actually we have subtract this amount of the solute from the amount of the solution, then we will get the amount of the solvent, because we know that solution is equal to solvent plus solute. Okay, to know the amount of solvent, we have to subtract the amount of solute from the solution. Understand? So here if you subtract 18 from 500, then it will be your actually 482. That means to prepare 500 gram of 3.6 mass percentage solution of sodium hypochlorite, we need 18 gram of sodium hypochlorite, and actually we have to add 18 gram of sodium hypochlorite in 482 gram of water. Understand? To prepare 500 gram of 3.6 mass percentage of solution of that sodium hypochlorite. I think you understand this calculations. Okay, understand? So this is very simple calculations. So in the next class we will discuss in details about the volume percentage, or volume by volume, or volume by volume percentage. Okay,